Hello everyone. Today we are going to have recording of chapter 7 similarity from maths 5312. And in chapter 7 we are going to answer question number 347. We will try to answer. Now first of all, let's go to question number 3. It says that according to figure 7.1, we need to examine parallelogram AEGI. It is the biggest parallelogram of the given figure, and identify several sets of congruent parallelograms and also triangles. Explain why they are. So I just wanted to draw that figure here initially, and from here, like we can even complete this one to one more parallelogram here, and now we have 1 2 3 4 parallelogram as it is here, and just to make it same, we can maybe color it. Maybe we can just color this one. Let's go to yellow, and this one also yellow, this one also yellow in color, and this one also yellow in color, like any one of them. Yeah. Yes, now we did that here. Like additionally, what we can do, like we just see the figure, like in this given figure we have some diagonals as well. So according to this, what we see here now, let's draw our segments also. When we see that from A to C and C to G, as we can see that it is a straight line. So, and likewise, like this straight line is parallel to BF line segment, and also it is parallel to DH line segment, because we know very well in parallelogram, like the two sides are parallel to each other, and these long two sides are also parallel to each other. And this diagonal, we can consider it as a transversal line which cuts the two parallel lines. So in this case, like the interior alternate angles are equals to each other, and from here, like this angle DCA, it is exactly the same as angle FCG, because they are interior opposite angles. They are opposite angles simply. And then similarly, like we can see all the angles are, what are the angles are equals each other. That is why we can easily say that the ABCD, AEGI, BEFC, CFGH, and DCHI. These 1 2 3 4 parallelograms, they are congruent to each other. Just as a proof, maybe we can measure, for example, angle of these two, like it is 90 degree. Wow. And these two, so it is 45. It means total is 135. And likewise, we can just check like here. This one is also 90 degree. This one is also 45 degree. Between this and this angle, it is 45 degree, and we see between this and this also will be 45 degree. So and likewise, let's check from here also. For example, these two sorry, like let's make it from here to here. Yeah, 45 degree. And this one, like that, if we do, it is 90 degree. And lastly, let's check from here also. Again, it gave from exterior angle, so we can just make it like this. What happened? I want to check the angle of these and this. Yeah, it's not giving here. Why? Because I just made a line segment from A to G directly. I was supposed to stop at the C point, so that maybe we can do it. Still, we can do one line segment from C to G if we draw now. And let's go to measure again. Where is our angle? Now let's see from C to this. Sorry, like from this one. No, I couldn't succeed that. Till we can see like it is 135 degree, like the 9 and the 45. It is so it is also, and here also we can see like this one and this one. Sorry, like this and this, it is 45 degree, and this one and this one, it is 90 degree. So like they are congruent, like this angle. There is another way also to show that, for example, this angle is angle of big parallelogram, and also it is angle of ABCD parallelogram. Because of that reason, whatever is the B of ABCD parallelogram, whatever angle it is, since they complete each other to 180 degree, A and E angle also supposed to complete each other to 180 degree, because A is also one interior angle of AEGI, like the big parallelogram. That is why we can see here, like all the triangles are congruent, as well as all the parallelograms are congruent. So we can see the another question. I guess it was the question. Are there any pairs of triangles in this figure if they are the shape is same but a different size? No, because as we said that again, like if we need to come here, since in these angle parallelogram sides, like the sides are equals to each other, so according to the given angle, whatever sides are equal each other, like here also in this size, like the same for same angle, and the one arm is same, so that the another side also will be same. That is why like all the triangles will be completely congruent. There will be no any different size of triangle here, we can say. So the next question is what? Next question. Identify a parallelogram that is larger than parallelogram ABCD but has the same shape. Create the interiors of both of these parallelograms. How are the angles, size, and the area of your second parallel? Yes. Now here actually we have seen already some part like the 40 and 90, and the 45 and 90 degrees, and 45 and 90 degrees, and this angle is 45 degree. We can maybe make it a little bit more visible by keeping here. This one we can keep here, and this one we can keep here. Yeah, like it is more clear now. This is 90 degree. If we need to check, this one also will be exactly same as the angle E, like the 45. Here only one thing we didn't check, like in question number 7, angles are already checked, the sides are already checked, and only the area. Since the area is multiplication of length and the width, uh, here like the simply if we say, let's suppose from here, if it is a h, like the height of the small parallelograms, either a b c d or b e f c, because it is a like the h, like that will be actually the same as if you draw from here, or if we simply from b to here, like if we draw the vertical line, what we see is here like this h, I mean this will be just the half of the h2. H2 is the height for the big parallelogram, which is a, e, g, and the I. What we can say is we say that this parallelogram is congruent to below parallelogram. That is why their height is same as the below parallelogram's height. So when together we add both of their heights, then in AEGI height will be double of small parallelogram. So for that reason, if it is, for example, this area is A, let's suppose, and as they are congruent, this area also will be A. and this area also will be A, and this area also will be A, and altogether small parallelograms ratio to big parallelograms ratio. I don't know if I will try to, my stylus is not with me, that's why, just a second. If I try to just bring this one here, maybe I can write a little better. I'm not sure. So like area of parallelogram ABCD, A, B, B, C, and D. If it is A, for example, if it is A, then the ratio to area of parallelogram A, E, G, and the I. Like this area is 4A, like the together when we have the ratio, like it is 4 times. So how we can say that one, like we can also think like this. If this is, let's suppose A as it is written here, if this is A, then definitely this part will be 2A, because these and this parallelogram are congruent. That is why in big parallelogram it will be the double of size. So height is also double. That is why A times H, or the 2A times 2H, like there will be ratio of 1/4 small parallelogram to big parallelogram.